All right, so let's talk a little bit about the time value of money. And I left it here on this slide because look at the compounding here. We had six compounding calculations to do, okay? This was a 3-year investment compounded semi-annually. The reason time value of money is so helpful is let's imagine now that we need to make that compound 36 times. Let's say that we invested it for 18 years compounded semi-annually, okay? Or let's say we invested it for 3 years compounded monthly. We would need to make that same compounding calculation 36 different times. It becomes kind of a pain in the butt, right? Just to be quite frank and honest. So the desire to not have to make that compounding calculation so many times led to the following formula. This formula right here, where your annual rate is R, so the 1% in this case would be R, and then the C is the number of compoundings per year. So let's say we are compounding it monthly for 3 years. So the C here would be 12. There's going to be 12 compoundings each year. And N is the number of compoundings you're doing. If we're compounding monthly for 3 years, that's 12 times 3, that's 36. So your N would be 36. So let's take a look at this. Let's calculate the $100,000 investment. We're going to compound it semi-annually for 3 years. We're going to get the following formula. Okay, we're going to take 1. We're going to add 0.1, the 10% divided by 2, the number of compoundings in the year. Okay, and that gives us 0.05. And then we're going to raise that quotient to the 6th power. And what that is going to, and that 6, remember, is the number of total compoundings. That gives us the answer 1.340095. What this number tells us is that for every dollar we invest, we're going to get a return of 34.0095 cents on every dollar. So if we have a $100,000 investment, we can multiply it times that 1.340095, and it will tell us what the future value of our money is. Okay. Now, beginning on page 346 of your textbook, you're going to see these time value of money tables. They are big. There's a lot to them, and this is the way that I learned how to do time value of money. Okay, it is the old school way of doing it. It's the method that has been used to determine TVM rates for years and years and years. Okay. We need to know how to use these tables. It's important that you understand where these numbers are coming from. So get out your book, look at page 346, and find the row for 6 periods. That's 3 years semi-annually, so 3 times 2. And you're going to find the column that intersects with 5%, or that 10% annual interest rate divided by 2. And you'll find that you get the number 1.3401. Okay, it's a slightly different answer than what we got with the formula, and it's due to rounding. They're not going to, these tables take up space on the page, cost money to print, so they're going to save a little space, and they're going to round it out to 4 digits. Now, are you going to get a different answer if you're multiplying times different principal amounts? Yes, you will. Okay, you just have to realize it is due to rounding. Now what I would like you to try is let's do the same thing for 3 years. Let's compound it monthly for 3 years, so 36 compounds, 12 times a year. You're going to get a 0.0083% interest rate. You cannot find that number on the table. It doesn't exist on this table. Okay, it doesn't go back that far for interest. This is why we use calculators. This is why we use Excel for finding these TVM calculations now. Okay, I'll still show you the formulas and the lectures and the PowerPoints, but my expectation is that you are using a calculator to come up with these answers, or you are using Excel to come up with these answers. There are future value, net present value formulas inside of Excel. Okay, so let's talk about the future value of an amount of $1. So what is the future value of $1 today? Okay. So it is the exact same formula, except now we're going to multiply the present value. What is our investment today? Okay. So what is $100,000 today worth tomorrow? Okay. So let's take our example. $100,000 times the present value rate that we found, 1.340095. That equals $134,009.50. This is much easier than making multiple compounding calculations. Okay. Again, I put this here as a reminder. These are just what all of your variables mean in here. If you have any questions about that, the future value of $1, please let me know. So we will also very frequently call this the future value of a lump sum. Okay. Here's the good news. Good news is that finance calculators, I recommend the BA2 Plus or the BA2 Plus Professional, but HP also makes a very good financial calculator. They are relatively cheap. They are worth the investments, especially if you're in the College of Business. If you're moving forward in accounting, finance, you're going to be required to have a BA2 Plus at some point. It is the calculator that is required in the College of Business. You won't be allowed to use any other calculator on exams. I'm pretty lenient about it in this class because a lot of you guys are freshmen or sophomores, but moving forward, you're going to want to invest in the BA2 Plus or the HP version of the finance calculator. I would recommend doing it before the final. They're about $30. You can get them on Amazon or you can get them at Staples, Office Depot, places like that. I don't think Walmart typically carries them, but I know I've seen them at Office Depot. I've seen them at Staples. I see them on Amazon all the time. So I will say this. There are too many different financial calculators for me to go over how to use them. They are all used slightly differently. So if you have one or you are buying one, it will be your responsibility to learn how to use it, to learn how to make these calculations with that calculator. Again, I'm going to say that I will highly recommend you invest in a finance calculator. It makes not just these TVM calculations easier in this class, it makes a lot of the calculations we did in this class easier. I know the BA2 Plus does break-evens, it does bond amortization, it does depreciation, cash flows, gross profit calculations. They just make a lot of what we do so much easier. So I would definitely recommend going out and investing in one. So let's talk about the present value of a lump sum. Okay, we talked about the future value of a lump sum. But what happens if we say, well, we want to have this amount in the future. How much do I have to invest today at this rate to get that future value? This is what we call discounting. Okay, if you look at the highlighted portion of this formula, what you will notice is basically the same, except now our future value formula is in the denominator, right? This will give us a rate of less than 1. The reason for this is because we are doing what we call discounting the future dollar amount, right? So you'll see what we mean when we start calculating these. But let's assume the same facts that we've been using so far, okay? So the $100,000 investment. If we use the same facts, 10% twice a year for 3 years, 6 total compoundings, we're going to get 0.746216. You can find this information in Table 2 that starts on page 348 of your textbook. Okay, that is your present value of a lump sum. Okay, what is this telling us? All it's telling us is that $1 tomorrow is worth 0.746216 cents today. Okay, so we're just looking at it from the other perspective. With the future value, we were looking at what is my dollar today worth tomorrow. Now we're looking at what is tomorrow's dollar worth today. Okay. The last part of time value of money is going to be what we call annuities. These are equal payments that happen at equal time intervals with an equal or constant interest rate. Okay. All three of those things have to be true in order for something to be considered an annuity. Equal cash payment, equal time interval, constant interest rate. Okay. Note that the interest is compounded at each payment date. Okay, there are different types of annuities. We are going to talk about very simple, basic annuities here. Okay, so let's assume that you have 3 annual payments of $5,000 starting on 1/1/24. How much money will you have when the last payment is made if you can earn 10% interest on that $5,000? Okay, so the first payment is worth $5,000, 0% interest. You put it in the bank, or $0 in interest. You put it in the bank, you're earning 10% on it, okay? So the future value there, $5,000. Well, The next year you've earned 10% interest on it, so your future value is $10,500. The next year you're going to earn 10% on that $5,000, and you're going to get on that $10,500, and you're going to get $1,050, giving you a total future value of $16,550. So that $5,000 payment made every year turns into $16,550, not just the $15,000 you would typically consider it to be. Okay, the way that, again, that was a simple compounding, 3 years. Well, let's say we have 25 annual payments, $5,000. Well, it would take a significant amount of time to sit and calculate each one of those 25 annual payments, right? And the interest that they're drawing, and the new value, the new value amount that they sit at. Okay, so the interest of not compounding, doing that many compounding calculations, we have a formula. This is our future value formula. Okay, future value of an annuity. Okay, so what you're going to do, and again, I hope you guys are noticing that our original future value formula is still being used. We're just making some updates to it. Okay, so you're going to take your annuity and multiply it times this quotient here. Okay, again, I've listed these out for you. R is your annual rate, so the 10%. C is the number of compoundings per year. It's being paid annually, so in here it would be 1. N is the total number of compoundings, so 25. Future value would be the lump sum of money at some point in the future. Okay, and then the annuity is each period's payment amount. So we know $5,000 is our payment amount each period. The X, what we're trying to find, is the future value. It's all just plug and chug. I know this is kind of it can be a scary looking formula, and you're wondering how you're going to remember it. Again, the calculator is going to help you do that, right? You just plug those numbers in and hit compute, and it tells you what your future value is, or it tells you what your annuity is. It tells you what your interest rate is. It tells you how many annuity payments you have to make, the number of payments you need to make, the number of compoundings. Okay, so those calculators, very useful. So let's look at a future value of an annuity example here. What if we wanted to have $1 million after we make monthly payments for 40 years and we could earn an 8% interest rate? How much must the monthly payment be? What should our annuity be each month? Well, we could use the formula, and it would look like this, right? 480 would be our N, 12 would be our C, 0.08 would be our R, and what we're looking for is our annuity, right? So we know our FV is 1 million, okay? So that is how you could find what your payment would have to be each month for 40 years in order to have $1 million in the bank if you got an 8% interest rate, okay? Now let's say, how much would you have if you made monthly payments of $300 per month? So let's say I can afford a $300 per month payment, right? I can put $300 a month into a savings account that yields 8%, or that yields the following interest rates. So if I did it for 40 years, at 5%, you'd have this much. If you did it at 6%, you'd have this much. If you did it at 10%, you would have this much. I mean, look at you would almost double your money if you got an additional 2% on your interest at $300 per month. So, you know, the value of compounding interest is insane, right? So nobody's investing at simple interest rates. Typically, people are investing at compounding interest when they can. So the final one we got to talk about is present value of an annuity. So we looked at the future value. What is the future value of these payments? Now we're going to look at the present value. So what is the present value of these payments? Okay. So what this is asking is, what is an annuity worth today? What is that payment worth today? And you can see here, once again, we've got our future value formula right here. Okay. And we've just, instead of taking this and reducing it by 1, now we're reducing 1 by this quotient. Okay. So again, I've listed everything out for you where PV is your present value. That's the lump sum of money you would have to invest today. Okay. And I will tell you this. In most financial calculators, your present value will need to be negative, or it will return a negative value for you as your present value. The reason for that is you need to think of it as, what do I need to give up? How much money do I need to pay today to get to that X amount of dollars, okay? So that's just a warning. You will see those listed as negative if you do buy like a BA2+. It'll show you your present value as a negative amount, and that's just because the assumption is that it is an outflow of investing cash or financing cash, one of the two. So let's look at an example here really quickly. Present value of an annuity. So what would 3 annual payments of $5,000 be worth today if the interest rate is 10% and the first payment is 1 year from today? Okay, so again, you could use the formula, right? You've got your annuity right here, your payment, $5,000. Okay, you've got your interest rate of 10 divided by the number of compoundings per year, which is 1, to the third power, which is the total number of compoundings, and then you're going to divide those out. You will see that you would have to invest $12,434.26 today to be able to withdraw $5,000 a year and end with $0 in the account. So that's kind of the other way of asking that question. How much would I have to invest today to be able to withdraw $5,000 a year for 3 years, with the first $5,000 withdrawal 1 year from today? And you would make a schedule like this. So that is time value of money. That's all we're doing for Chapter 11. These are the only things you need to worry about from Chapter 11. Okay? Don't worry about the decision making and all of that that's in the book. I would still recommend going through and looking at the book, reading through the book. But if you do want some additional materials, let me know and we will find some for you. All right? Thanks, guys.